Crash Course Instrumentation, Episode 14, Thévenin and Norton Equivalents. Welcome back to Crash Course Instrumentation. High voltage sine. Today, we're stepping up our circuit analysis game by learning how to simplify complex networks using two powerful tools: white tick mark, Thévenin equivalents, white tick mark, Norton equivalents. These concepts let us shrink big, messy circuits into simple models, just a source and a resistor. Perfect for predicting load behavior, testing circuits, or designing measurement systems. Down pointing finger, let's dive in. Brain, why simplify? Imagine you're trying to understand how a sensor or transmitter will respond when you plug it into a big control system. You don't want to analyze the whole system, just what the device sees. That's where Thévenin and Norton equivalents come in. They let you reduce an entire network down to just one voltage, or current source and a resistor. This makes it way easier to calculate voltage drops, predict current flow, optimize load matching, analyze worst-case scenarios, chart with downwards trend. Thévenin equivalent circuit. A Thévenin equivalent replaces a complex circuit with a single voltage source, fifth in series with a resistance, RTH. It's what your load sees when connected to the terminals. How to find it? 1. Remove the load. 2. Measure or calculate open circuit voltage equals fifth. 3. Short the sources and calculate equivalent resistance equals RTH, chart with upwards trend. Norton equivalent circuit. A Norton equivalent is the flip side, a single current source, in parallel with a resistance, RN. And here's the kicker: light bulb. Thévenin and Norton circuits are interchangeable. Fifth equals in times RN equals fifth, RTH RN equals RTH. You can switch between them depending on which is easier to use, or depending on the nature of the load. Electric plug. Practical example: say you've got a circuit with a 24-volt power supply, a 1000 ohm resistor, and some other resistors in a weird configuration. You want to know how much voltage a pressure sensor will actually see when connected. Instead of solving for every branch, you 1. Find the open circuit voltage at the sensor terminals, fifth. 2. Find the total series resistance seen from that point back into the network, RTH. 3. Done. Now you know how it will behave when the sensor is connected. Use Ohm's law, V equals fifth times load. Load plus RTH. This is especially helpful when working with low-powered transmitters and input cards with fixed input resistance. Hammer and wrench emoji. Field applications. White tick mark emoji. Designing signal conditioning circuits. White tick mark emoji. Matching analog sensors to input cards. White tick mark emoji. Evaluating input loading on op-amp circuits. White tick mark emoji. Predicting voltage drop in multi-drop networks. White tick mark emoji. Simulating unknown loads in circuit testing if your signal seems off. Thévenin analysis can help explain whether it's your sensor or your circuit that's responsible. Wrench. Quick tip: source loading test if you ever want to test a real system's Thévenin resistance. 1. Measure open circuit voltage, V1. 2. Connect a known load resistor, R. 3. Measure new voltage, V2. Then solve, RTH equals R times V1, V2. V2. Graduation cap. Final takeaways. White tick mark. Thévenin equals voltage source plus resistor. White tick mark. Norton equals current source plus resistor. White tick mark. They're fully interchangeable. White tick mark. Use them to simplify, test, and diagnose. White tick mark. Must-have technique for every instrumentation. Tech. Thanks for watching Crash Course Instrumentation. Be sure to check out the mod PDF on source and load, and join our Facebook group for more great discussion. Next up, Episode 15, where we'll apply this knowledge to maximize power transfer and efficiency.